All right, welcome back. Today we are jumping into a really fascinating project that sits at this incredible intersection of AI, child health, and language. It's really a story about starting from square one to build a tool that could help kids who might be struggling in ways we can't easily see. Just think about that for a minute. We all know a kid with messy handwriting, right? And we usually just brush it off as, being careless or needing more practice. But what if it's actually something much deeper? What if the way a child is forming their letters is a signal, a cry for help, even, about a challenge they're facing that they can't put into words?
Okay, so first things first, let's really get a handle on the specific problem we're talking about here, because it's a very real and often misunderstood learning disability.
So this condition has a name. It's called dysgraphia. And look, this is way more than just bad spelling or grammar. It's a learning disability that actually affects the physical act of writing, those fine motor skills you need to just hold a pen and make the shapes of letters. It can make writing physically exhausting and incredibly frustrating.
And when you put them side by side, wow, the difference is just night and day. On one hand, you have typical handwriting, which is pretty consistent. But with dysgraphia, you start to see the signs of a real struggle. You've got letters of all different sizes, words floating off the line, maybe letters or even whole words just missing. Sometimes letters are even flipped backwards, like a B for a D. It really shows you the daily battle these kids are up against.
Now, identifying dysgraphia is already tough, but the problem gets even trickier because of a massive blind spot in our technology.
You see, we have all this incredible AI that's amazing at recognizing patterns, but there's a huge catch. The vast majority of these tools, like the ones trained on the famous MNIST dataset, they basically only speak one language. They've been trained almost entirely on Latin characters, the ABCs we use in English. They're completely lost when they see other writing systems.
And this really gets to the heart of the matter. Using a tool trained on English to try and understand the nuances of Sinhala handwriting is, well, it's just not going to work. The shapes, the strokes, the way the characters connect, it's a totally different world. It really is like being handed a subway map and being told to find a fracture in a bone. You're using the wrong tool for the job, period.
So you've got all this research and these huge data sets for languages like English, Chinese, even Persian. But for Sinhala, the script used by millions of people in Sri Lanka, it's been a total data desert. There was simply no foundation, no starting point to even begin building a tool to help these kids. And that's exactly where this research comes in. The team behind this project saw that gap, and they decided that if the tool they needed didn't exist, well, they were just going to have to roll up their sleeves and build it themselves, from the ground up.
And this wasn't just some abstract lab experiment. It started with real people. 84 children to be exact, all between the ages of 6 and 11. They gathered handwriting samples from kids who had been diagnosed with dysgraphia and from kids who hadn't to build a brand new data set for comparison.
They had a very clear, systematic plan. First, collect the actual physical handwriting samples. Second, scan and digitize them into images. Third, clean up and standardize those images, that's called preprocessing. And finally, label each one so an AI would know what it was looking at. Now this part is really clever. They didn't just have the kids write down any old words. They were super strategic. They went through Sinhala school textbooks and picked specific words that are known to be tricky, words with really complex strokes and letter combinations. It was basically a targeted stress test designed to bring out the exact challenges that are unique to writing in Sinhala.
Okay, so you've got a stack of papers with handwriting on them. How in the world do you turn that into something a computer can actually understand and learn from? That's what we're going to dig into next.
In the end, they created a dataset of 373 handwriting images. Now, the breakdown here is really important. Just under 20% came from kids with dysgraphia, and the other 80% came from their non-dysgraphic peers. That comparison is absolutely vital. It's the secret sauce that allows an AI to learn to tell the difference.
But here's the thing. You can't just feed a bunch of raw photos into an AI and expect magic to happen. You have to clean them up first. This is a super important step called preprocessing, and it's all about getting rid of the extra noise so the AI can focus on the one thing that matters, the handwriting itself.
So they created this really cool pipeline. First, they strip all the color out, turning the images to grayscale. Then, they use some smart algorithms to get rid of any smudges or random noise. After that, they isolate the writing itself, basically making the letters pop against a pure black background. And for the final touch, they refine and resize every image so they're all in one standard, consistent format. What you're left with is perfectly clean data ready for an AI.
And then comes the last step, which is so simple but so essential. Every single one of those clean images gets a tag. It gets a 0 if the handwriting is non-dysgraphic, and a 1 if it's dysgraphic. That's it. This is the answer key that the AI is going to use to teach itself what to look for.
Look, just building this data set is a monumental achievement, a huge win. But it's not the end of the story, not even close. You could say it's the launchpad for everything that's coming next.
And the team has some really big, ambitious plans. Now they can use this data to train powerful AI models, specifically things called convolutional neural networks, to automatically screen for dysgraphia. They also want to make the dataset even bigger by working with more schools and hospitals. And get this, they want to start collecting online data from tablets, which can track things like how hard a kid is pressing with the pen and how fast they're writing. But the end goal for all of this is crystal clear. Develop real tools that help kids get diagnosed earlier and get the support they need to succeed.
And this is maybe the most powerful takeaway of all. The impact of this work goes so far beyond just one language. The whole process they developed, from how they collected the data to how they cleaned it and labeled it, it serves as a blueprint. It's a repeatable playbook that other researchers can now use to help children in other languages and communities that have been overlooked.
So, when you step back and look at the whole picture, this entire project started to fill a very specific and very unfair gap for one community. But in solving that problem, they created a powerful method that could shine a light on hidden struggles all over the world. And that leaves us with a really exciting question to think about. They built the blueprint for Sinhala. Which community will it help next?